What's up, Adam? How you doing, man?
Very good, very good. How are you?
I am excellent, dude. We just got done talking with Kyle from Banana, and it's Banana.dev. Banana.dev, I think, is the actual address, but he's an ex-Cruise machine learning guy, and dude, I got some killer takeaways from this, but I want to hear what you thought first before I tell you mine.
Yeah, very interesting discussion. Lots of like, it's interesting to see someone with such a sharp-minded focus on just their problem. Like, we're just going to do this thing.
Mm,
And I love that. Like in the conversation, he said that actually certain things we just say we suck at that. That's not us. Come
so
back
good.
later, kind of thing. That's missing, I think, from a lot of what people try and do. They're like, oh yeah, we can do that as well. Oh, yeah, and actually, it's nice and refreshing. And like I said, this is I think what Banana.dev are doing is a very in a very competitive space. It's not well
Mm.
understood, so he's taking an opinionated but like quite pragmatic approach to just getting stuff done. So I really like that, and some brilliant material within the conversation.
That laser focus, man. It was killer to see that. I totally agree with you. I also think he had a quote that I might put on a shirt or sweatshirt and try and put it in the merch store, which you all can find, as you know, if you've listened to this podcast before. And you can check out the link for that in the description. But the quote was, paying for idleless GPUs is really dumb. I need that on a shirt. It's killer. Also, the three different like axes which
Yeah,
he looks at serving things, definitely worth keeping an eye out for that. And we are labeling this. Do not listen to this unless you're going into production,
yeah.
because this is very much like production kind of content, quality stuff. I loved it. Kyle is, again, he's the CEO, I think, of Banana.dev, ex Cruise, and he did robotics at CMU. The guy's doing stuff. And
Knows
then
his
we did a
stuff.
little personal exploration at the end.
Also, worth saying, super generous. He's like hit him up for advice and tips and stuff. He said he was really forthcoming with his time and he wants to kind of contribute to the community. So really, really cool.
Oh, so true. Yeah. So feel free to reach out to him. He just wants to help. He was like, it's not going to be a sales call. It's just, I want to help people get into production. So there we go. All right, man. Let's get into it. Talk for a minute about Banana Dev, man. I got to know what's up with that. And I always think whenever I see Banana, whatever, incorporated, Banana Enterprises, it reminds me of like we're going back to our roots, and it's so easily relatable. I love it because you can draw a banana that's really easy and it makes for a great logo. But then it makes me think like we're very kindred spirits with the banana because of our monkey roots. I want to know what's going on with you and Banana Dev.
Yeah, so just like the origin of the naming. Yeah, basically there's like a common meme in the dev community of like using bananas for scale, and that's what we want people to do. Is we want people to use banana for scale. The other more personal reason is I like to say banana's the next apple, because it's like if you're pitching something, it's pretty easy. People like fruits, but I think from the dev side, it's banana for scale. That's what we're going for. Yeah.
A
Amazing.
It's
really,
pretty simple.
really
We had
good joke once you've explained
Yeah.
it.
we had different names before. We were a boost with an e at the end, but we heard several pronunciations like booste, boosty, and
Mm.
we're just like, no, this isn't working. So hence
So
the
what are you
rebrand.
guys doing? Can you tell us a little bit about Banana Dev before we jump into this full conversation?
Yeah. So point of Banana is we make productionizing ML really easy. So you come to us with a model. You've got the quality you need. You want to go to prod. We give you back an API that you can call in 2 lines of code, and then you can use your model just like it's like GPT-3 or like some third party, except it's your baby, it's your model. And what this means is like it'll scale naturally. We keep the costs low. We make the latency fast. We do all that stuff you need. You don't have to worry about it. So you focus on the quality, which differentiates the business. We do the undifferentiated production in prep.
Hmm. So what's the great vision there? Is it just to help more people get into production, more people realize value with machine learning?
Yeah. So the motivation was I was at Cruise before. we were productionizing ML, and we realized that it takes months to just get a model to the quality you need to go to prod. And then once you go to prod, it takes another few months to handle just all the long tail of stuff that breaks, like from autoscaling, spinning up machines. If you want to do like something like serverless GPUs, being able to just handle high volume, optimize latency. Now you need to know all these tools. Like suddenly you have to know Docker, K8, you have to know CUDA if you want to optimize inference. And it's like, wow, this isn't what I signed up for. I'm a data scientist or whatever. I'm working on model quality, and now I have to do all this. So I kind of like my broad motivation is like accelerate the creation of really smart machines, like AI, like whatever, ML, whatever you want to call it. And I think productionizing is just like a way we can do that. It hasn't been solved yet. And it's just starting. Like the pain point is being hit by more and more companies every day. So the vision would be that like when you go to production and you want to scale machine learning, you use Banana for scale. That's the simplest term. Yeah, and right now we have like early offerings with like serverless GPU is the most valuable offering we have right now, because we can just say, hey, go to prod, we'll spin up GPUs 10 times faster, so you only pay for usage, and this can really help if you have a lot of idle time.
So that's really interesting. So like utopia, ideal world, I don't have to hire any machine learning engineers now. I can just, my data scientists can interact with your team and your tools, and it's just, so that's the big sell. Because, and then the thing I would get onto following that is there's a lot of competition in this space, right? And people are trying to figure this out. It's very young. Is that the goal really, to kind of take that headache away from companies?
So what we've seen is like two cases. So there's either the team doesn't have infrastructure engineers, and yeah, their data scientists will talk directly to us. So this might be an early startup. They've built the model, and now they're like, I don't want to spend months hiring and then wait for them to build something if you can just do it. So that's kind of the speed to market value prop. The other is the team is actually like, we want to hire, we need infrastructure engineers, but we want those engineers to be empowered using the best tooling. And then we try to work directly with them and provide that tooling. So they need flexibility. They don't want to be like vendor locked, right? Nobody likes that. So that's the other angle.
Yeah, and then the other thing I was going to ask them was, we had a conversation with James Lamb a while back, and he talked about how they built, I can't remember the name, it was his previous employer. He'd done the hard yards and done the machine learning engineering system there, and they found that the outcome of that was it was optimized for one very particular type of model and workload. And if you're saying early offering being GPUs, I'm guessing then computer vision, is that the kind of early stage stuff that you're doing at the moment? Yeah.
Yeah, so like large ML models like are typically on GPUs. You need that to do quick inference. So we do language models, computer vision. Text to speech is actually a really popular use case.
Okay.
Because it's a large batch process. Yeah, and the second like pain point typically from customers is like spinning up a model can take minutes. So right, like with stuff like GPT-J, it takes 15 plus minutes. We've got it down to seconds. And so that allows for like serverless offerings. So all that optimization is done on the GPU side. You can use CPU, it's just very slow. Typically, a slow inference affects your user experience, but in some use cases it won't. So we'll take the CPU approach now.
So I wanted to get into a little bit of what you were talking about right before we hit play, or hit record, I should say. And that is like some of the common pitfalls that you've seen on the engineering side when you want to take a model into production and also like then start to scale it. Can you hit us with some of the things that you've seen over your tenure?
Yeah, I'll start with the most common. The first step that teams take is they built out a model. They're used to notebooks. They have their Google Colab, whatever, and then they go to prod and they say, hey, we're going to use the same setup. So we've seen teams spin up a notebook and then offer it as a Flask app, and literally if you close the laptop, prod goes down. We've seen like as janky as that, because it's like that's how you did dev, right? We've seen people spin up basically like team up sessions on a remote machine, again like port forwarding a server. So they load their model directly into a Sanic or Flask app, and then they try to just return the inference result. And this is usually the first step. And It's great. I love the mindset of like ship fast. The problem is, firstly, you can't scale it. So if you have any sort of traffic spike and you're doing inferences that take on the order of seconds, now your user experience will tank quickly. The second is you don't have a way to roll deploy updates. So prod just continuously goes down. So we see this problem where folks they typically already have customers. They're wanting to offer ML to them. So like a better solution, right? They don't usually start with ML. So they built this thing, they put it in prod, and now they're like, oh man, I have hundreds of people using this, and like I don't know how to I don't know how to fix this because if I change anything, prod goes down. So that's like the second main blocker, and that causes a lot of headaches. So fixing that takes weeks. So that's the first area to save time. It also causes your users headaches. So I think the takeaway here would be like when you're going to production, you really have to think about your end user and like. I know there's this whole do things that don't scale, but if you're deploying something to an already scaled audience, you really have to think twice, right? Like I worked on cars before at Cruise, and it's like you can't just push something to production when it's a car on the road. You have to think about there's already an ecosystem out there. There's people using this thing. There's people interacting with your product in extraneous ways. So that's a big thing. Like, and once you do, it's hard to revert going to prod when you don't have infrastructure to like push a new update. you've just rolled over users to this broken thing, essentially. Yeah.
I'll just say +1 for the word janky. Someone chinned me for saying that the other day, and all of a sudden everyone thought I'd made it up, and I'm sure I'd heard it elsewhere. So I'm glad that you've used the word because it's definitely not me. The thing I wanted to ask, because you've touched on this, and it's something that like gets discussed now and then, and I think I did a post the other day about roles, right? And touch on the fact that, okay, all of a sudden you've got data scientists, specialists, difficult to acquire skill set, need to learn a load of other stuff now, Kubernetes, Docker, all this stuff that wasn't in the Coursera course I paid for. And so one thing that I constantly want to like think like, you've done the hard yards, yeah? Is there such a thing as machine learning engineer, or is it actually just software engineering? Like, is there really a difference, or is it just good software engineering applied to ML?
Yeah, I mean, you could generalize that and just say, is there such a thing as engineering, or is it just solving problems using tools, right? So that's personally the way I think of it as a founder. Is like I'm just like, hey, I treat organizational problems as systems, and I'm like the organization's a systems of people, like literally workers, processes, whatever. And then machine learning is just another way of basically making a computer do a thing. That level of reduction may annoy people because I know there's purists that like thinking that there's this software 2.0 with machine learning. You could argue that neural networks as an architecture, but then you have to dissect like even machine learning. There's traditional support vector machines, k-nearest neighbors, methods, principal component analysis that aren't using neural nets. So there's this architecture. Like there's the control flow and then the data. I mean, so I haven't dug in too much into it. I just see it as like problem solving, and I think neural nets, in particular, in machine learning, are like a really powerful tool. So, and I'd say like if you learn how to use those, you're an engineer that uses that tool. But you should use any tool that you need to solve your problem, basically, as an engineer, in my opinion.
No, very cool. Okay, no, I suppose it just comes from if it's a useful model, then use it, right? I guess. So okay, then to flip that same question, I guess then, who's in the team? Is it software engineers you're hiring? Is it data scientists, infrastructure guys, and gals?
Yeah, yeah. So typically, so early on in a company, right, you want to hire generalists, people that just hack, they make stuff work. We started extending into folks that did a lot of consulting on ML. So we have engineers that have worked like directly with folks like Andrew Ng, have done like large consulting projects. They have a lot of data points. They know how to solve a problem. So we think we need people that can do two things: understand requirements from a customer and then figure out how to build it. There's so much going on in productionizing for ML that if you have those skills, it's great, but adaptability, I think, is more important. So a lot of us on the team didn't have the perfect skill set that we'd be hiring for now, and we think it's changing so fast. We're just like, here's like the basics. Like maybe, for example, can you code? That's good. Do you know how servers work? Do you know Python? But then it's like, all right, you're gonna have to learn Kubernetes, Docker, Pulumi if you want to do like infrastructure as code, all this other stuff. But we don't like require that up front because it's like you'll figure it out, and we might be building the next Pulumi, right? Like whatever's needed.
So that's something that you touch on, which for me is probably one of the most important parts, and what I see a disconnect from interviewing so many people over the last 2 years is how not enough people think about the way to interpret the problem or actually using machine learning to solve a problem as opposed to using machine learning to do whatever it is that you need to do and forgetting about the problem completely. And so when I think about Banana and how it's like I can come with what I have and I can bring it, and then you guys help me scale and you help me do everything to productionize that. Have you thought about, like, is there not a disconnect with, well, what about if what you're productionizing, what you're operationalizing isn't actually solving the problem that they want? Because I imagine you're not going upstream and saying like, hey, are we solving your problem? We're just going to package it up and get it out there and have it so it's bulletproof.
Yep. We had a previous iteration of our company where this was the failure mode. So, and what we did is we focused on quality and productionizing. That was a mistake of the company. You should pick one thing, do it well when you're starting. And we didn't align on requirements. And so we would spend a lot of time, and we basically had this amorphous, like, set of just like a customer saying, I want high quality. And then we don't know what that means. And then we keep working and they're like, it's not good enough. For productionizing, we focused in there now. Same thing happens, right? You need to really, so to make this tangible, if you're trying to understand the requirements of somebody, trying to productionize a model, here's what you need to have them write down and align on. You need to know inference latency. How fast does the inference have to be? You need to understand traffic spiking. So like, how much does it need to scale up or down? You need to understand price. How much are they willing to pay for this hosting? And you need to understand how quick does their model load into memory. Because when you're talking about production, it's not model quality anymore. It's the user experience and their business, how much they're paying you, that matters. So quality is like the training, everything. And then when you're in prod, it's like, there's other things like reliability too, but basically comes down to, does it scale? Can I afford it? And is it fast for my customer? Because that's what they need. If you don't have those numbers and you start building, you have a very high chance of being disappointed because you will do weeks of work. You'll come back and they'll say, oh, this is like a 30-second inference. I need 7 seconds. I need 500 milliseconds. And we're like, whoa, like that's, but now it's going to cost you this much. And they're like, I can't afford that. And we're like, so you can think of it almost like this cube. We call it like the production cube. So there's 3 axes. There's like latency, there's cost, and then there's like how quickly it can scale. And we look at like, are we able to meet those 3 constraints for our customer? And if not, we just tell them like, hey, we're not here yet. We'll do a service fee, and then we'll do some custom work. And sometimes if it's a really big deal, we'll just buckle down and be like, they obviously need this. So, but yeah, you really have to understand in numbers like what the customer is looking for, what they expect, and then set those expectations before you build, I think.
And then how does it work with like, because they're coming to you at the end of the road almost, a lot of shit can break upstream. And so like, how do you make sure that your SLOs are met if stuff is breaking upstream? And like, how can you tell them that, hey, that's actually your part that is breaking, not our part?
So you mean everything, the way we partition it is they own quality, we own productionizing. So if they tell us like, hey, the model's not good enough quality, or our customers don't like it, we say, hey, like that's not up to us unless it's something to do with latency, like inference speed, and then price, like we can't scale, then we'll come in. So we have a very clear division of ownership. It'd be cool to grow into those other areas, but right now we're just purely production inference.
And like, if you have data pipelines that are breaking upstream, is that part of the quality? also, and you're saying, look, I'm not getting what I need from you guys, so I can't do my job.
Yeah. So at the moment, what we take from a customer is we say, sorry. So right now we have customers send us the model artifacts, so like the weights and the architecture, and then we say, hey, we're going to load the weights into the model architecture. We're going to host it fast. How you create those weights, that's up to you. Your data pipelines, your notebooks, everything. That's pre-production. We think that can change in the future, but like right now, it's just a matter of like, how do you 10x in one area? Right now we 10x in production. If you come to us and you're paying like $10K a month for GPU hosting, we can probably bring it down to like 1 or 2K. So that's the thing. And then we proudly say we suck at the other stuff. Like we don't do that yet. And I think this is kind of like a meta thing, but it's kind of relieving as a founder to be able to confidently say you suck at certain things and say you're really good at something, rather than saying you're just like a dev shop and you can do everything. Because then the question is like, well, why don't I just use all these other services? So you really have to 10x in something to win in this market.
I think that's a really powerful mindset to have across the board anyway. I really like that. I want to go back a little bit, because trying to extract some of that experience and knowledge for listeners. You went through a bit of a bullet list on your fingers there of stuff that you need, right? Is that the same if so the scenario is I'm a data scientist in a company that's finding its feet with ML. I've got a model that I like, I want to put it into production. Is that list the same, or what's the kind of biggest thing to focus on? And actually, are there any resources that you've written up, like a blog post, that we could point listeners at? Because I think that would be really helpful.
So it's a great point. That sounds like a piece of content that we should write. I don't think we have yet. Let me try and distill it here, though, to TLDR for a listener. So you have a model, you're trying to go to production with it. First thing you always need to ask is what's best for the customer, right? So the thing to note is that the thing customers care most about, they don't care how much your model costs behind the scenes. That's your cost. They care about how much they're paying, and they care about how fast they get a response. So if you're doing a consumer application, latency is going to be your number one thing. Customers need fast response time, because fast response time means higher retention, engagement. Like imagine you built a chatbot and your ML takes 20 seconds per message. That's going to suck way more than if it took half a second. Versus if you're doing batch processing, something like, hey, send us your job and then we'll finish it, get back to you when it's done, then you don't have to care about latency as much. Maybe now price is the angle. But customers care about how much they're paying, how reliable the service is, how fast they get the value they want. One interesting insight here, just about customer psychology, is people just assume reliability. Like we have Amazon, GCP, Azure. People assume 5.9 uptime. If you don't have that, you're not even playing in the same field. So you can't come in with like 80% uptime and expect customers to vibe with your product, unless you're like MVPing with like a handful of trial users, right? Once you're actually scaling up, you're trying to grow, your retention curve will just be destroyed by uptime, because people will say, but like all these alternatives are more reliable. Like why? Like people just don't think it's a problem anymore, right? It's kind of like ordering food and it takes 3 hours to get to you, and you're like, this doesn't take 3 hours. This takes 20 minutes with Uber. So yeah, so you need to know that about your customer, and then
Yeah, I think people forget that. Like it is, an artifact of the modern world, I suppose, that like I'm going to compare every website to things like the Google homepage and stuff like that without really considering the differences in resources and expertise and knowledge and stuff. Have you any advice for people then that are dealing with unrealistic expectations on that production end? And when, again, for like, I'm machine learning engineer number one, I'm trying to get something set up. How would you go about sort of, I suppose expectation management?
Sure. So you're talking expectation management with customers, right?
Yeah.
So again, like we need to, let's anchor to these these axes again, right? Price, latency, reliability. Let's say those are like the big ones. Customers don't care about scale because they're one person. Your business cares about scale because you're meeting many customers. Customers just want reliability, speed, price. The expectations along those vary. The one customers typically care about most is price. My advice, that I've, and this is from what I've done across like dozens of different projects I built and what I've seen from successful companies, is you should start with people willing to pay a lot. So try to bias towards people that have money, right? And then treat price optimization as unlocking the market as you go, as like a consequence of scaling. So basically what you should say is like, yeah, you should basically ask, like, if you had a flow chart for it, you should say like, how do I get, okay, so I have this glorious product vision. It's going to change the world. Great. How do I give this to one person in this week or this next week, whatever? And how do I find the one person that's willing to pay for the price it's currently at? If you can't find anyone, that should be a flag. Like, you should really be sussing that out, right? Because everything, at least personally, that I've built, we find people that are willing to pay. Like we've had customers come in and just offer hundreds of thousands, millions of dollars to solve a problem. So if you can't find somebody that's willing to pay like upfront, very high, you might not be solving a big problem. Then once you have that one person, be like, how do I find 10 customers? And now you're going to exhaust the people that are willing to pay a lot. And now you're going to have to just consequentially, like the goal is to give this product to as many people as it can provide value to. So you're going to have to lower the price just as a consequence. Again, reliability is expected. So we just covered price. Start high, optimize low. Like that's how everyone does it. Uber started with like special vehicles, right? Like these like fancy, what was it, like a black limo service, right? Then they rolled out these like economy. If they started with economy, they might have not been able to like to have the unity con to grow. I don't know if that's for certain, but like you just look at the first principles, look at a business and just feel like you don't have money yet, you're not big, you can't be penny pinching. Reliability is assumed, so people just want high uptime. I know it's depressing, but like that's just the world we live in. Like people want good products. You're competing with giants. In terms of latency, this one's interesting. With latency, it doesn't have the same properties as price and reliability. With latency, sometimes, so for example, we have customers where like if the product takes this long to respond, people don't use it. And then as the latency comes down, it's kind of like unlocking that adoption curve. And from what I've seen just from like dozens of customers, it's not as easy to just say, oh, let's find people that are willing to have bad latency, as opposed to like, let's find people that are willing to pay a lot. Like latency is it's a spikier distribution. Like some people are okay, some people aren't. You kind of just have to like, you kind of have to hone in and be like, are people not using my product because the latency sucks? And you have to like identify, is that the problem? So for example, there was a bunch of stuff with like GPTJ. People were putting it in prod, trying to do chatbots, and people were just like, this isn't fast enough. Like we need better latency. But then you optimize GPTJ for latency, and now it's like the quality's not there. Like it's not like you do like quantization and you like make it smaller or whatever. So
yeah. No, I can see that because a lot of the stuff we do at Origami actually is like it's kind of a hard threshold. It's like the latency can be whatever, but there's a threshold at which you're unusable kind of thing because it's very batchy and we've got like systems built on systems kind of stuff.
And also, I want to just point out hard truth being thrown out there. Like, if people aren't willing to pay top dollar for what you've built, then that should be a red flag. That is such a good quote. Like, if you can't find someone to pay a pretty penny for it, then you're doing something wrong.
So maybe we could re-distill, like we kind of had like a ramble through stuff. We had to distill it really simple. If people aren't bugging you for your product and willing to pay a lot, you might not be solving a real problem. That's just hard. Reliability is assumed. Start high price. For latency, that's where your main work's going to be. Like with latency, you need to be like, am I unlocking the market by lowering it? With price, just start high all the time. With latency, try to get it low. Don't start by trying to get price low. So that's basically how I distill it into a chart. It's like high price until start with lowering your latency. That's what drives customer experience. Find the people that are willing to pay a lot for that experience, and then lower price as you scale.
You know what I love, Adam?
What do you love?
Getting a new job.
Really? Okay. Well, funny you should say, actually, because Origami's hiring. We're hiring at some pace as well. I kind of keep losing track of what we've got going on, but definitely on the tech side, we're looking at data folks, data engineers. We expect more to come, but any kind of software engineers or engineering managers that listen to this, please reach out. But I think there's something you're looking at doing to maybe help with this.
Dude, we created a jobs board, and you can see on that jobs board right now, and Instill AI is looking for a founding engineer. You've got Zorro US looking for a senior machine learning engineer. There's all kinds of great jobs being posted on our jobs board. So whether you are trying to hire somebody or you're trying to get hired, get over to our jobs board at MLOps.palette.com. You can also find that link in the description below. That's it. And or just go work for Adam. Go work with Adam. That would be awesome.
That'd be cool.
At Origami. All right, let's get back into it. So there's some things that we mentioned before we started recording, and one of them was like, hopefully what this podcast will be today is something for someone who is already in prod, right? Like, don't listen to this podcast unless you're in production or you're going to production. Are there things, what are some certain things that you want to talk to people who are in production about that you haven't already said?
Biggest thing is paying for idle GPUs is really dumb. GPUs are expensive. And right now, AWS, GCP aren't offering serverless GPUs. And that's kind of what motivated our team, because we're like, this is so dumb. Like you wouldn't leave your car on and pay for a gas bill. You wouldn't leave like your TV on and pay for electricity bill. So like, why do people leave compute on that they're not using when it costs more than like gas and a television, electricity in some cases? And so I'd really be, if I was looking at a team that's already in prod, I'd be asking like, how much idle compute time are you using? Could you put that into hiring an engineer, right? It's really easy to burn 3 to 5K a month on compute. And when you look at 3 to 5K, it's like you could hire an engineer for that. So I would ask people like, how much are you spending on like dead compute, and how many people could you hire with that? And just like try to figure out like, how can you get that down is valuable. Yeah, I think that's the big thing. And then the second would be look at your latency tolerance. So if you hit a traffic spike, I already mentioned latency affects how much your customers use your product. So really dissect like, what is the worst latency your customers are getting? That'll give you a lot of insight into what's working with your product. Sometimes when we just fix that, we realize that like, hey, 10% of users are getting just awful latency, like multi-minute wait time, and some people are getting seconds. And then you fix that. Like you can add like auto-scaling, you can better distribute workloads. That can directly impact retention. So this is the main thing I'd say to prod is like, watch your bill, make sure you're scaling, basically.
I think as well, like, you've not really spoken about it that much, but there's a real significant human cost to learning this stuff. Like actually going through the 6 to 9 months where you figure all this out for yourself can be quite stressful, difficult, painful, whatever, can lead to big catastrophes. So one thing that I wanted to touch on, we've talked about kind of how to optimize like the decision-making process, manage requirements and things. On the technical, like more deeply technical side now, is there any like, what's the one hiccup or hurdle in productionizing ML systems that maybe doesn't get talked about enough, or some people might be unaware of, or have you got an interesting anecdote about something that really stumped you that was kind of unforeseen?
Yeah, I could speak of this personally. I didn't know how to productionize ML before. Like I learned this on the job, right? So maybe the angle here is maybe this will help others that are just about to productionize foresee a few hurdles that, so like entrepreneurs especially tend to think stuff will take a couple days and then it takes weeks. So I can like de-risk a couple of those and go through the process of like what I got stumped on. So the first is like machine orchestration. So like, again, you have one replica running of a machine, you have your server, that's great. But the moment you need to scale, you need to have, you need to be able to have health checking to like auto start a machine, spin it down. And now to do that, to be able to start a machine from a script, you need to have a consistent environment, which means you need to learn Docker. And Docker is a headache if you haven't done Docker. And then once you want to start doing, like say auto scaling, then you want to start doing bigger orchestration with tools like Kubernetes. That was the second big headache for me to figure out. Like it's a fun tool, but it's not as fun when you're trying to serve demand and you're blocked on it. It's more fun when it's like a weekend project and you're learning. So Kubernetes, Docker. Then the third big hump you're going to get to is that sometimes you're going to want to use GCP. Sometimes you're going to want to use AWS because they have different offerings that work for you. Now you have to learn a whole suite of like how to operate in a console with like TPU nodes or TPU VMs or like GPUs on AWS with EC2 versus GCP. And it almost seems like they intentionally make it really difficult to do both because they want to have that vendor lock. And so you're going to spend like, dude, I have like an encyclopedia in my head of all the terms with AWS, like setting up like warm pools on EC2 with like instance template. It's just like, you have to know all that just to be able to orchestrate resources. That's going to cost you weeks, like as an individual, if you haven't done it.
The documentation is really good as well.
Yeah, like, so exactly. So the third thing that is going to come in that would probably be really, so I'm trying to explain it from what's helpful to you, not just like what the headaches are. So the first is like learn Docker, learn Kubernetes, learn Pulumi. That one's been really cool, or some other infra as code. Basically, because that lets you write effectively some Python code that spins up the AWS resources, and you can do that and like without having to learn the console. So that'll save you like a week of just becoming an AWS certified guru, basically. Let me see what else. Then I think the other headache was like, so again, really simple customer request is somebody's like, can you make my model 20% faster? Just the inference, just make it a little faster. But I can't pay a lot more. And so we're like, okay, like let's figure it out. Now you need CUDA, or you need to know like GPU programming. You have to optimize kernels. And then that's assuming you're a deep CS background, like you understand how operating systems work, how drivers work, you can do that. If you don't, that's going to be a learning curve. Then you have to learn this whole new language construct and this whole paradigm of programming for GPUs. Then you want to do GPUs, that's a whole different type of programming. Now you need JAX. So just for latency, there's all these tools. They're all their own headaches. If we zoom out, I'd be like Docker, Kubernetes, Pulumi are probably the biggest bang for your buck. If you had to learn 3 tools sooner than later, that's what I wish I had learned from day one. I kept prolonging it because I was like, I don't want to have to learn a new tool. But those will get you, if you know those 3 tools well, you'll be able to set up autoscaling, restart logic, reproducible environments, and use Google and AWS interchangeably. You'll just have to do the work, but you'll be able to.
One thing that I find interesting and fascinating talking to a lot of SREs is the idea of like, what is it called? Chaos engineering, and how to do chaos engineering because it sounds like what you're talking about is very much focused on this, like scaling up, scaling down, and making sure that you have the SLOs in place. How do you look at chaos engineering? Are you purposefully going through there and testing the resilience and testing theories that you have when you're scaling up and scaling down? And what are some things that you focus on when you do that?
Could you define chaos engineering for me? Is it like extreme programming? Or like
so it's like, basically it is intentionally bringing chaos to your system to test it out and see how it does under stress. And we had someone on a few weeks ago, or actually last week, and they were talking about how it was like you want to bring this chaos in because you want to have a theory about what will happen when this chaos is introduced, and you want to see if your theory is correct, just in case out in the wild that actually does happen.
Yes, you set up like services that shut off regions, shut off infrastructure, just like sort of once in 1,000 events. They just do it regularly, so that it was a Netflix thing, I think, wasn't it, that led to them being super reliable.
Mm-hmm. So your question is like, how do we do chaos engineering, or how do we approach that type of
exactly
testing?
How do you think about that kind of just basically like keeping the resilience and keeping the lights on?
Mm-hmm. Yeah, so when you're a startup, it's a fine balance of being resilient, but also over optimizing, like not over optimizing. So the way I kind of look at it is, okay, we're trying to serve some customer. If we haven't served them before, what are the ways this could break? Just like make a list. Like what are the, like, I think the problem is like engineers get stuck in their head a lot thinking of all these cases that don't exist. And then the customer just uses this tool in a really simple way and everything breaks. So I think it's like, I would just say be your customer, and especially if it's a consumer app, like just be the customer, use it as the customer, and look at like what are the hot paths going to be, and then distribute it as like what are the common use cases, what are the common ways this could fail. So for example, like you don't need to stress test Korean servers if you don't have servers in Korea at the moment. Like you don't have to do all your region deployment. And we've had this, right? Like we've launched servers for customers in like South Korea, and so we have to start thinking about that. So we'll ask ourselves, if I'm a customer in South Korea and I'm using Banana, what's the first thing I'm going to care about? Probably latency. So when we see like, what's the latency if it's in the West Coast? What's the latency in Korea? We just check it. We're like, and then we ask again, like zoom out, does that matter to me? And then we might be like, hey, it's a batch job, which doesn't affect retention. So actually it doesn't matter. And then we're like, cool, let's just not worry about it. So it almost sounds too simple, but it's like, just be your customer, try to like get in their shoes the best you can. And that's one, going to help you make better business decisions, but two, figure out like what to stress test. And that'll avoid the problem of like an engineer coming to you saying, hey, I've tested like all these specific sub-regions of things, which is like, that is great. And again, like if you're working on autonomous cars, you need to do that because the consequence of not doing it is you could cause irreversible damage and you can't mess up. But when you're deploying like SaaS or something, you need to just ask like, what are the actual like real failure modes that can happen? Because your resource constraint is a startup too. The equivalent with autonomous cars would be like, hey, we're deploying cars in, say you're trying to deploy in Palo Alto on like nice open roads, and you're only launching during sun. Well, then you should just say, we're not going to drive at nighttime. Like we're going to test the day, we're going to pass these cases, and we're going to be very clear that we do not drive at nighttime because we don't support that yet. So with ML, you can do the same thing. Like latency doesn't matter for this customer's use case. So we don't need to worry about those types of spikes. Yeah.
So as you were talking about this, I have a favorite question that I like to ask all of our guests. And I want to ask you it before I jump into some of your website and your personal website and some of the great blog posts that you have on there. Do you have any war stories for us? What can we learn from your wrongdoings?
Yeah, the hardest part is picking one.
That's a true engineer right there. Yeah. That's basically everyone.
I think, okay, let me just give a really concrete one. If you're using Redis queues, make sure they're not public, or else people will start throwing shit on your Redis queue. If it's a public, so we had a production, back when we were really early on, we had a production Redis queue that was open, and we started getting like prod traffic was coming down. We're like, what's going on? And somebody had thrown a bunch of, like, so basically we would take a task off a Redis queue and then look at what's the script running on the task and then try to run that script. And somebody was trying to do remote code execution. So they were putting a URL to their own bash script that basically wiped the machine and then started mining Bitcoin. And they were putting it in our Redis queue and it was spreading out across all our GPUs. Huge headache. Just like, if you keep, so basically like, don't keep stuff public. Like you will get hacked. It's not even like, you might think, oh, nobody has time to do that. And the thing is, it's not time. It's just people have bots that scan. They use something called Google Dorks. So you just write Google queries that search for failure modes, like in the URL, like SQL injection, whatever. And then they'll automatically find your site, just like a crawler would find your site in post spam. So that was a big one. I think, trying to think of like, yeah, that's I'd say it's like, that was a huge headache, and it was such an easily preventable thing.
I saw a demo of that actually from a senior Microsoft salesperson, and went through a whole tech demo of how Azure is like it's like the most hacked or attacked site online or something, and he turned off some of the security stuff that they normally have, and this new instance of whatever it was getting within seconds. It was getting like 20,000 attacks a second from all this automated stuff that was just like trying to break in and stuff. It was really quite impressive. They say, look, like we can't protect you against this, but
I think the other example I'd give, I can't go into the exact example, but I can give enough context that like to really not do it. You basically, if you're deploying a tool that people can use, you really need to understand what they're using your tool for. Like I can't explain that enough. If you don't understand how downstream people are using your tool, really bad things can happen. Like if they're supporting something that you don't support, if they're causing harm, if they're breaking the law, and it will happen if you build tools. It's surprising. Like you'll build a hammer and say, this is for nails, and somebody's gonna throw it at someone's window. You're gonna be like, what the heck? So this is just really kind of a similar thing to like, don't leave stuff public. But at the same time, it's just like, look at how people use your tools, understand it.
All right, so let's get into a little bit of this personal stuff that you have. And I think it's awesome that you put out this personal blog and we found it. And so I have to ask some questions on it. You have a really cool post about just what do you want in life? And there was something, there's like a footnote at the bottom that you edited out, or you changed your original post to from going for I want a long life, and now it's like I want to live hard and die fast almost. Can you talk to us about that and what's the catalyst behind that?
That's so amusing. So like the fact that somebody saw that, because like, so how I blog firstly is I just write in prod on there. Like I try to go there and I say this is a new post, and then I think about it, but I don't think too much about like who's reading it and stuff. I just say like, hey, this is valuable to me. I hope somebody else does. Basically, I had this kind of realization. So I've been training for ultra, and I got rhabdo, which is like basically muscle breaks down too fast. It gets into your blood and your kidneys stop working. It really messed me up. So I highly recommend if you see that happening, you should get checked out. But basically what it kind of made me think was like, I didn't regret the process of training to the point where that happened. I kind of see it like, it's just like how I want to look back on my life. Like if I was like summiting a mountain or something, right? And I saw myself and I passed away on that mountain. The two questions I'd ask myself is, was the mountain this guy was climbing big? Like, did it look inspiring, or was I like outside of a Walmart on a hill that I just passed out? I just died. I'd be like, that's not inspiring. So I want to be like, am I doing something big with my life? The second is, this happens all the time. Like you excavate someone from a mountain from 1,000 years ago, and then people say like, how hard is this person pushing? Like if I found myself, I'd want to look at myself and be like, yeah, like I was pushing to my absolute maximum. Maybe I wasn't like the smartest about it. Maybe I wasn't like I didn't have everything figured out, but it's like I pushed into my absolute limit. So the distinction is that it's a tougher change. Like maybe this will be different in 5 years in my life, right? But I realized that for me, prolonging, like trying to live a really long time, was sacrificing my ability to push myself to my limit. And I feel like it's just such a privilege to be able to hit a true limit that I don't want to lose that. It doesn't mean hurt yourself in the same way over and over again. It doesn't mean inflict harm for the sake of harm. It means like I want to train for an ultra, and if something like kidneys stop working, I want to be like, wow, what a privilege to be able to hit that point where like it's so rare to hit that level of like you just can't keep going. And now that I know that, I won't do it again, right? But I wouldn't want to live in a way where I don't get to experience those extremes. Yeah.
You're looking for the red line.
That's kind of, yeah. So it's kind of like my value. I want to live healthy. I want to live long, right? Like I get that, but I don't want to do it. I don't want to do it by tiptoeing around life and avoiding things that could push me to my limit. So like I had if I look back at my life, the other thing I was really proud about is like I did a Kilimanjaro hike a few years ago with like food poisoning and like blacked out multiple times, had like oxygen was low, had to get like carried into camps. It was like brutal, but I was like, I look back at that and I'm like, man, that's like one of the things I'm really like proud of or happy of. It's like that was like such a limit that I didn't think I could hit. I feel really, really tragic if I hit the end of my life. Even if I lived to 100, I look back and I was like, I didn't ever push past 90%. I would feel sad, even if I lived an extra 10, 20 years. So, whereas if I look back and I say, yo, man, I messed up, this is it, or like I get diagnosed with something, maybe I have a year left, I'd want to make sure that I don't regret not pushing hard enough. So,
Amazing to hear this. And I love this philosophy side. It might become more common on the podcast. And if anyone wants to hear more philosophy from our guests, let us know. I know this is a technical podcast, but that was a very inspiring answer. And it makes me think about how I'm living a little bit differently. And now let's finish it here. This has been awesome. And
cool.
Kyle, I thank you so much. If anyone wants to check out what Kyle is doing, go to Banana.dev and you will see all of his stuff. He's pushing hard on his company too. You just heard the philosophy. You heard everything. I mean, there was some real gems in there, man. I appreciate you coming on here and teaching us some stuff.
Perfect. If I can add one thing is if you have any questions about going to prod, like free of charge, just like message us, hit us up. Like we want to help in any way. If you're building your own thing, just at least come to us and don't make the same mistakes. But like we're happy to give advice because it helps us learn too about like the different pain points. And yeah, good luck basically if you're taking on that challenge.